Hi, I'm Chris, N9CVR. In this video, we're going to go back and look at those measurements we were talking about a couple of weeks ago and see where they apply to the technician exam. So these test questions are from the technician exam. You can know that from the T here. T is for technician. There's also a G and an E for general and extra. And then 5A is the group of questions from the question pool that we'll be going through. Later on in the video, we'll also be looking at some of the stuff out of 5B, although 5B also goes into decibels and things like that, we're not going to cover that in this video. One thing to note here really quick, this is the 2018 to 2022 exam, so these questions are basically going to expire any minute here, but the reason I'm not concerned about this and doing this video anyway, I guess my point in doing this is not so much to have you memorize the answers to the test questions as it is to teach you a way to approach these questions, so it really shouldn't matter what question they give you on the test. You should be able to answer it. So with that, let's go ahead here. So T5A01 is the first one in T5A. It says electrical current is measured in which of the following units? So T5A is, again, a lot of definitions. And here, essentially, they're asking for what does current mean? Or what units do you measure current in? It helps me a lot to visualize electricity as kind of like your plumbing system at home. Your water coming in, municipal water. So the current is kind of the same thing as the flow rate. It's the amount of electrons going through the circuit at any given time. And without too much, let's just kind of start with a definition. That is measured in amperes. Amps, electrical current, that's kind of how you want to do it. Volts is more, everybody's familiar with like 9-volt batteries, 120 volts coming out of the electrical outlet, things like that. Voltage is more like what pressure your water is coming into the house at, whereas the current is the number of gallons per minute, if you will. Watts here that's a power thing. We'll talk about that later. And ohms has to do with resistance. That's a topic for another video, so we can safely ignore that for now. Hey, speaking of power, electrical power is measured in which of the following units? And we just said it's watts. So there we go. Amperes, again, is more flow than power. The difference being power is basically if you want to think of it like a flow rate times a pressure. So you can get a lot of power by having a lot of flow rate, or you can get a lot of power by having a lot of pressure, but you can get even more if you have both. Amps, again, that's the flow rate. That's not quite the correct answer. Volts is the pressure. Yes, that will help, but when we're measuring power, we're talking about amps times volts, which is watts. And again, they throw in ohms, but we're kind of ignoring that for now. So going with that analogy there, what is the name of the flow of electrons in an electric circuit? Well, you should pretty easily be able to answer that already. Hey, it's the current, because the current is the flow rate. Again, the voltage is more like the pressure. Resistance and capacitance are things that we're going to talk about later. Resistance and ohms kind of go together. Capacitance is another topic we'll get into. Now here's a word or a term that you're gonna see every once in a while, and I'll show you how to kind of learn it, but realistically, you don't hear this very much. So it says, what is the electrical term for the electromotive force, or EMF, that causes electron flow? Keep in mind, EMF can also stand for electromagnetic frequencies, but here we're specifically talking about electromotive force. The way I remember this is electromotive force. Well, force is kind of like a pressure, so that kind of means a voltage. So this electromotive force, voltage, they basically mean the same thing. Ampere hours, well, that's a flow rate times the amount of hours. That's kind of more like a power measurement. Inductance, capacitance, those are things we're not dealing with in this video quite yet. So the important thing to get, though, is electromotive force, or EMF, and voltage. That they mean the same thing. What is the name for a current that reverses direction on a regular basis? So let's talk about what they mean, reversing direction on a regular basis. They're not talking just about, let's say this T over here is minus and this T is plus, and we're just going in a straight line from minus to plus and then minus to plus again, and just keep doing that. Nor are they talking about this thing where, you get halfway between the two from minus to plus, and then kind of quarter of the way back, and then 3/4 of the way, and then back to half, and then 7/8, and then a quarter, and then all the way. That's kind of random. They're specifically talking about something where the current, again, this T is minus, this one is plus. You have electrons flowing from minus to plus here. Then at some point it reverses, so this T becomes minus and this one becomes plus, and now the electrons are flowing the opposite direction. And however long that took, wait another same amount of time, and now this one is minus again and this one's plus, and now they come flowing back the other direction. So you have this flow this way and then back this way and this way and this way, and it alternates back and forth very periodically. So the correct answer is alternating current. Direct current is what a battery does. That's, here's my minus, here's my plus, and all of the electrons always start at minus and end up at plus. And that never changes. You just keep going, minus to plus, minus to plus. Circular current and vertical current, they just threw words in there. Yes, those are English words, congratulations, but they are not correct answers. T5A10 says, which term describes the rate at which electrical energy is used? So the catch here is we're not just talking about electrical energy, we're talking about how fast that electrical energy is used. Again, the mechanical, or if you will, fluid power equivalent is horsepower. So, okay, fine, you're pushing really hard, but if you do that for a very, very short amount of time, you haven't used much power. If you push for a really long time, but you don't push very hard, you still haven't used a lot of power. So power is really defined as how hard you are pushing for how long. So the rate at which electrical energy is used, that is power. Current is just how often, how many electrons go from minus to plus, really is all it is. Resistance, again, we can pretty much throw that out right now. In future videos, we'll talk about that. And voltage is more pressure. It really has nothing to do with a rate. So probably the best way to remember this is a rate is having to do with power, because it is it has to do with how long you are applying this force, essentially. that is the combination of current and voltage. All right, here you should be able to answer this really quick. What is the unit of electromotive force? And that is the volt. We normally call electromotive force voltage, and therefore the units are volts. Everything else is, we already talked about amperes, that's flow, current flow. Ohms have to do with resistance, we'll talk about that later, and watts have to do with power. What describes the number of times per second that an alternating current makes a complete cycle? So this one we got to break down a little. First of all, let's talk about a cycle. Let's define a cycle. So here I've got this H at the end of wavelength and this Y at the end of frequency. And let's say H is negatively charged and Y is positively charged. So my electrons are going to want to flow from H to Y. But then at a certain point, Y becomes negatively charged and H becomes positively charged. So the electrons flow back from Y to H. And then at some other time, it switches again. So H is negatively charged, and now the electrons come from H to Y. And we kind of have this back and forth. One thing to understand, well, I guess first, finishing the definition of the cycle. The way we define a cycle is, so if I track an electron, it starts with the H and it moves over to the Y, and then it comes back to the H. That's one cycle. If it starts with the H and moves to the Y, that is one alternation, or half of a cycle. So really what we're looking for is something that goes positive and then negative before it goes back to positive. That's a full cycle. Something else to keep in mind is a definition for alternating current. We just said it goes back and forth, okay, but it's not like it goes positive and then negative and then positive and then negative. It just kind of turns on and turns off. That's not what we're doing. An alternating current is going to look more like a sine wave. It's going to kind of build to a peak positive value and then die out, and build to a peak negative value, die out, build to a positive, build to a negative, and keep going like that. a cheap soldering iron is basically what it turns out. And I got that fixed, and I've gotten myself a really cool antenna that I think you guys are going to like too. So make sure to tune in next week for that. Apart from that, yeah, we'll see you in the next video. 73.